Hi everyone! Today, we're tackling a fun coding challenge. We want to count triplets in an array. These triplets must have a special property. Their sum needs to be perfectly divisible by a given number d. Imagine you have an array of numbers, say 1, 2, 3, 4, 5, and d is 3. We need to find all unique groups of 3 numbers from this array whose sum, when divided by 3, leaves no remainder. For example, 1, 2, 3 sums to 6, which is divisible by 3. That's one triplet. 1, 3, 5 sums to 9, also divisible by 3. That's another. So, how do we find all of them efficiently? Let's start with the most straightforward approach, brute force. This method is easy to understand. We will use 3 nested loops. The first loop picks the first number, I. The second loop picks the second number, j. This j must always be greater than I to avoid duplicate triplets and using the same number twice. Finally, the third loop picks the third number, k. This k must be greater than j. Inside the innermost loop, we calculate the sum I plus j plus k. Then, we check if this sum, when divided by d, leaves a remainder of 0. If it does, we increment our counter. This process continues until all possible combinations of I, j, and k have been checked. This brute force solution works correctly. However, it has a time complexity of n cubed. This means if our array has n elements, the number of operations grows very quickly with n. For small arrays, it's fine. But for large arrays with thousands or millions of elements, this approach becomes incredibly slow and impractical. We need a smarter way. So, how can we make it faster? We can optimize this by using a key insight from modular arithmetic. We only care about the remainder of numbers when divided by d. The property a+b+c, %d equals 0 is the same as a%d plus b%d plus c%d, %d equals 0. This is powerful. Instead of 3 loops, we can try to use just 2 loops. We iterate through the array with our first element, I. Then, we use a second loop for our second element, j, making sure j is greater than I. Now, we have I and j. We calculate their sum's remainder. Current _sum _m equals I plus j %d. What remainder do we need for the third number, k, so that the total sum is divisible by d? We need k, %d to be d, current _sum m, %d. Let's call this our target _remainder. Now, the challenge is to efficiently find how many numbers k, after j, exist that have this target _remainder. If we can quickly count these ks, we can add that count to our total. A common technique is to pre-process the array or maintain a frequency map of remainders for the elements we haven't processed yet, or for elements that come after j. For example, we could build a frequency map of remainders for all elements from j plus 1 to the end of the array. Then, for each j pair, we just look up the count of target _remainder in this map. This reduces the problem significantly. While building such a map for every j might still be slow, more advanced techniques involve building prefix or suffix counts of remainders, or updating a single frequency map as we iterate. The goal is to find the third element in constant time, 1, after doing some initial setup. This improved method can often bring the complexity down to n squared, or even better depending on d and the exact implementation, which is a massive improvement over n cubed, for large inputs. This makes the solution practical for much larger datasets. Thank you so much for joining me today and learning about counting triplets with sums divisible by d. I hope this explanation was clear and helpful. If you found this video useful, please give it a thumbs up. Don't forget to subscribe to the channel for more coding challenges and explanations. Your support means a lot. See you in the next one.